Good morning, everyone. Can you hear me? Am I audible to you?
Yes, sir, you are audible, but your screen is small.
Yes. Is blur? Is it blur?
No, sir, it is in the one block format, not a whole screen visible to
Yeah.
us.
You can do one thing. You can pin it. Pin, and then you can make the bigger window. Please. Okay. All are facing the same problem. All are facing the same problem. Reply. Come on. Reply. All are facing the same problem. Can you able to see the bigger window? No.
Yes,
Yes.
sir.
So one has to pin that small window, and you can able to zoom it. Okay, so good morning everyone, and this is the first lecture of our subject, microcontroller and applications. For understanding of this subject, we require some prerequisites, perhaps which you might have studied in your previous semesters, maybe third semester, fourth semester, in an ADIC, and so on. So some sort of information of last or digital subjects is extremely essential, along with some sort of basics of C programming should be known to us. This is what a prerequisite required for this subject. I will not be going into detail what we are discussing because it is more difficult at first lecture to explain the entire syllabus. It is easy for me, but definitely not for you. It will be difficult for you to understand what I'm saying as a part of syllabus. But just I want to brief you about the content and how we are moving ahead and what is prerequisite for this subject. So for today's lecture, hardly we will collect one definition, one point, and then we go ahead. Okay. So what is the prerequisite? For this subject, we require the basic information about the counting systems. In the routine life, we implement or use the decimal system. Decimal system is having 10 different symbols. Symbol is like 0, 1, 2, 3, 4. It's a symbol. All the symbols. And last symbol is 9. So we have 10 different symbols, and with the help of 10 different symbols, we can write in terms of decade values. And with the help of that, we can write any number. So numbering system should be known to us. I will not be discussing in detail. I repeat, I just want to brief it. So first of all, you should know a numbering system. Existing system is decimal system. So in decimal system, different symbols. We have 10 different symbols, right from 0, 1, 2, and last will be 9. And in the decade value, we define the base of 10. So this system will have a base of 10. So you count in terms of base, 10, 20, 30, 14 in that way. So the base of this system is 10. And with this, try to implement any number or write any number. Okay, that is known to us. But what we require in our subject, we require the this number system like a binary system, octal system, hexadecimal system should be known to us. So if somebody asks me what is binary system again the symbols, but it has only two symbols. The name itself suggests binary, so it has two symbols. So a system which we require is binary system. Here, the available symbols are only two symbols. One of them is 0, other one is 1. So obviously the base value of this system will be of 2. So The base of this system will be 2. And with the combinations of 1010, we can able to write any number which is required for us. If somebody asks me what is the number that is 25, I will try to write in terms of 1010 with the base of 2. So that system should be known to us. And octal system, of course, for this subject, we are not directly required the octal system, but definitely we will require one more system, that is counting system, hexadecimal counting system or number system. So that should be known to us. Now, hexadecimal number system, the name also, I will suggest us, it consists of different 16 symbols. Okay, the first symbol is 0, 1, 2, and likewise. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 solo symbols are there. 10 will be the combination of 1 and 0. That is not required. We have to take some more symbols. So instead of 10, we will write A. So this is up to 9, then A. For 11 is a combination of 1 and 1, but 1 is already symbol taken. So we'll consider one more symbol as a B. So this is B, C, E, E, and the last will be F. Total symbols available in this system will be 0 to F, 0 to 9, then A, B, C, D, E, F. Total 16 symbols are available. So obviously the base of this system will be 16. So symbols of base. The base of this system is 16. That's why it is called as hex. So any number which we try to write in a hexadecimal system should be a combination of either of the symbol present here or many symbols present over here. So in that way, and then how to convert the hexadecimal system numbers to binary to decimal number. This conversion should be known to us. That is the prerequisite of the subject. So please go back and not now after the lecture. Please try to understand or recollect the points how we convert decimal to binary to hexadecimal. That should be known to us. Okay. So this is the first most requirement of our subject. I just want to build up required references for the subject. So please keep in mind that this is extremely required for this subject. Secondly, what else we require before we start this subject, which is abbreviated as a MCA, microcontroller applications. We require the knowledge of ADIC, more specifically a digital circuit. Analog circuit is not required till we reach to the applications, but for first few chapters we require a digital system. And one should understand presently in which area we have to work, because when we were in the first year, no, we might have discussed about the PN junctions, diodes, and till the last year we reached to a very, I mean, operating softwares, very high level language softwares. In between this, where we are working in a sixth semester, that one should know. Let me start with the content which we have seen in the first year, or maybe the initial portion of electronics. We know the PN junction called as diode. So, so we know diode. Diode is what? A combination of P and N junction in a short. So we know diode. It consists of only PN junction. Doping levels are depends. Doping depends on doping level. We can understand what is the minimum voltage required. It is called as knee voltage. That fundamentals might be known to us. Now, what happens? How diode looks? I mean, it's just a region. This is a diode. One of them is P, other is N. Now, what we are doing? When we club these two diodes together, it will form a transistor. Of course, we'll not discuss about the doping level. I just want to club them together as per as the region is concerned. P type, N type regions are there. So when I club these two diodes together, I will get transistor. Either NPN or PNP. How they look, I mean, don't know the lights, P, N, P, and so on and so forth. So I just want to bring you towards a syllabus. Diode is known to us. When we club these two diodes together, we may get NPN or PNP. Doping levels are different. That we have to understand. Now what I'm doing, I'm just going to club. I'm going to combine multiple transistors together. So when I combine multiple transistors together, I will be getting the gates, OR gate, AND gate, NAND gate, NOR gate, likewise. So when I club the transistors together, I will get number of gates. Symbolically, they can show by OR gate or AND gate or a NOT gate. So these kind of different gates that we can obtain when when we club these transistors in the TTL fashion. This is one device. So what I'm doing, I'm going to just club. I'm just again combining number of gates together. Maybe in a parallel, maybe cross connected, depends upon the input and output. When I club these different gates together, I'm going to get flip flop. So flip flop is what? It's a combination of number of gates. So when I club these gates together, I'm going to get flip flops. Flip flops are having multiple inputs, multiple outputs, or two inputs, two outputs. As per my requirement, our requirement, we can do it. Normally, it has two inputs and two complementary outputs present. So that is what a combination of different gates. I will get RS flip flop. I will get JK flip flops. I can get toggle flip flop, T type flip flop. So I may get like this RS when we club this R and S together, we obtain toggle. So D flip flop, T flip flop, and so on. So these are number of flip flops. They are combinations of gates that you might have seen, or if not seen, look into that. Now, but flip flop as a device, if somebody asks me to draw a diagram for flip flop as a device which can be used for a microcontroller, what I will show, I will just try to show it like this. This is a box which may give me the output as a 1 or a 0. So I can say the different language. It will store either 1 or a 0. As we move ahead, no, we are going to be more familiar with the words, typical words, which we use for this subject, which you never heard. Never heard means not you haven't used those words in the routine language of communication. But for this subject, we require some different words, and based on those words, sentence will be fulfilled and this will be understandable to somebody else. So this is what a flip flop. It consists of it stores either 1 or a 0. I'm going to club number of flip flops together. 1, 2, 3, 4, like 1, 2, 3, 4. It looks like a string. 1, 2, 3, 4, 5, and so on. Every flip flop will carry either 1 or 0 as per our requirement. When I club this flip-flop together, this is called as register. Normally, registers consist of 8 flip-flops. In a microprocessor, controller, I haven't started that one. A register is what? A combination of flip-flop. So when I club these flip-flops together, I'm going to get register 1, 2, 3, and so on. Now this register can be you operate as per my requirement. They can be made all 0, they can be made all 1, they can be made 1, 0 alternately. I can toggle the bits 1 to 0, 0 to 1. So as per our requirement, I can modify, rearrange, change the contents in that register. So why not club these registers together? When I club these registers, maybe in a parallel or in a series as per our requirement, and maybe in terms of thousands of registers, lakhs of registers, if I club them together, that will give me a combinational circuit. Okay, so combinational circuit is what? Or sequentially. Sequentially means they will change as per sequence, one after another. And combinational means what? Simultaneously, they can change the contents. Not, we will not go into that detail. What I mean to say that? I mean to say that it's called as a combinational circuits. Consists of number of registers. So when I plug number of registers, I will get combinational circuit. That is for limited number of registers. But my application tells me that you need to connect thousands or lakhs of registers at one time. And that will lead to the large scale integrated circuit or a very large scale integrated circuit. So combination circuit size of that will decide LSI or VLSI. So this will lead to either large scale integrated circuit or very large scale integrated circuits. So if the lakhs of registers are combined together, that is called as this one, very large scale integrated circuit. ICs are there, fine. But I said no, the way I can modify this register to make all 0, all 1, toggle the bits and so on and so forth, addition, subtraction. This circuit is having registers. So why not use that large scale circuit for a computational process like addition of something, subtraction, multiplication, division, logically ANDing, logically ORing. So those are a computational usage of that VLSI. When I convert this VLSI as per a requirement to go for a computation, let me repeat. When I use this VLSI as per our requirement to go for a computation like addition, subtraction, multiplication, division, and or XOR, this is called as processor. So this is called as processor. Or very obvious, no, processor. Processor processes the thing. Processing what? In terms of mathematical operation, addition, subtraction, multiplication, division. In terms of logical operations and or XOR, it has to process. But then why it is called a microprocessor? The device, I mean, this is IC, this is my IC, consists of number of registers and it has been used for processing of addition, subtraction, multiplication, division, or and XOR, and so on and so forth. The processes require some time. Every process requires some time. But the advancement is done in such a way that every process of addition, subtraction, delete, copy, what it may be, or add, XOR, that requires microseconds. Of course, the processing is done in microseconds. So this processor will be called as a microprocessor because a time required will be in terms of some microseconds. This is called as microprocessors. I haven't shifted to microcontroller. I reached to microprocessor. Maybe in the next lecture I will discuss about microcontroller. Now Very easy, no? To understand. This IC consists of number of registers. I have programmed it in such a way that it can be used for mathematical operations or I can use it for logical operations, and that will give me a microprocessor. Consists of number of registers. But then sometimes I may use it for a small application. I may use it for a large application, small applications. Suppose if I want to manage the firing of my bike, I will having a limited operation, no? Small operation. I will go for a small version of this processor. Washing machine or in automatic washing machine, we use microprocessor. But then when we want to go for a smaller scale application, we will convert this microprocessor to microcontroller, and that is dedicated for a small applications, small memory handling, small input devices to handle, small output devices to handle, and dedicated function. For that, I will go for microcontroller. But I will tell you the usage of processor. Now, microprocessors are so advanced and they have been developed by various companies. Right now, Intel is most popular among them, and we have reached to the generation. I think i7, i9. I don't know the next one is. We have used i5. So, right from the first processor, the first processor was 80. No, it's not 8084. It was 4004. That was the first microprocessor developed by Intel. At the same time, Motorola is also building the same microprocessor. It has to go for a compression process. So in the older chassis, they used to use this particular 4004 processor. Then it has limited operation, small memory, limited input devices, limited output devices. Maybe require some more advanced version. Intel, I'm going to write all Intel series. The same has been developed by uh, Motorola, same developed by General Electronics, and all this. And they were contemporary companies. So they developed 8008. So likewise, in 1951 till this day, there will be a generation or development in the processes. Microprocessors are going to be developed very fastly. They have to handle large memories. They have to handle large input devices. They have to handle large output devices, and they will just go on developing their series. I'm going to list out quickly. 4004, 4008, sorry, 8008, 8080, 8085, 8086, 186, 286, 386, 486, 80 processors. When they feel that the number is going to be larger one, they shifted that version to new version, that is Pentium 1, Pentium 2, Pentium 3, Pentium 4, then Celeron, dual core, core to duo, quadra core, 8 core. Likewise, they move ahead like i3, i5, i7, and so on. So these all are developed by Intel only. At the same time, AMD is also developing all this, but depends upon the market strategy. Intel has got much bigger success, you can say. So this is what a microprocessor. Now this is no longer remains to a microprocessor. It becomes a nanoprocessor. Okay, so some other time we will discuss on that. But this is what advancement. So we are working over here. We don't have to go in this series, no problem. But what is meant by microprocessor? Microprocessor is a device which has to use for a computation purpose, addition, subtraction, multiplication, division, or and XOR, and so on. Nothing else. Apart from this, it will not do anything else. Of course, as per our requirement, how to use those functions, mathematical or logical to get the result. That is our task. And for that we write a program. Otherwise, a processor will go for a mathematical or logical operations only. Advanced series just I have mentioned over here just to understand in which area we are working right now. And then how to convert the processor, microprocessor to microcontroller, probably that we will see in the next lecture. This is just a look of the area, or you can say a background to understand this subject, MCA, microcontroller and applications. Just a minute. So, firstly, I discussed uh, the counting system which we require. Then we have to understand in which area we are working. This is the area. This thing already we have seen in previous semesters. Next series we will not discuss, but we are focusing on microprocessor. More specifically, we are discussing on microcontroller that we will see. So that is point number two. Now we have just reached to microprocessor. Now we'll try to bring that word to the appropriate or synonymous word which we require for our subject. For that, one must know the microprocessor. Just as I say, no, I am very particular about words. Here, at this point of time, I said that this device will do mathematical operations and will do logical operations. Let me concise it. Mathematical like addition, subtraction, multiplication, division. Logical means what? Logically or, logically and, logically inversion. So at this point of time, I say that this processor will do only the mathematical operations and logical operations. But then how to do it? It requires a central processing unit. This word is very well known to you. So let me draw a block. This is called as microprocessor. Next lecture will convert processor to controller, microcontroller. But processor should be known to you. Okay. Now task is what? Task is perform the operation. Let me give you an example. The operation is 10 plus 20 is equal to 30. This I want to write, or this I want to get. My problem is very simple. 10 plus 20 is equal to 30. What is 10? Data. This is data. What is 20? Data. This is data. What is 30? Of course, 30 is a result, but the result is again data. Fine. So, this is actually result, but result will be in terms of data. Is it sufficient? No. Addition. Addition, subtraction is an instruction. So, I will say that, let me write the other color. This is known as instruction. So my program or my objective is to deal with data, instruction, and at the end, I'm going to get result. Now, to accompany this or to obtain this, not accompany, to obtain this processor will not work alone. It has to take the help of some peripheral devices. Peripheral devices like to connect any input output, we require the peripheral devices like keyboard, monitor, mouse, are called as peripheral devices. I mean to say that data should be given by me as a programmer. So connect this, I require input device. Keyboard is required. For data, I require a keyboard. Keyboard is required. Result, to show the result, I require monitor, LCD screen. I require output device. And instruction. Instruction is like addition, subtraction, multiplication, division, or add. Now these instructions are to be taken from a source that is called as memory. So I require memory. Now what I want to showcase. I want to showcase if this is a task to be performed by microprocessor, this device has to communicate with input, output, and memory. For what? Input to accept the data, output to display the result, and for memory to accept the instruction, addition, subtraction, and so on. So this will not work alone. It has to accompanied by peripheral devices. One of them is input device. Task is over. Other one is output device. And third one is memory. So somewhere here we require memory. This is called as MUP. MUP means microprocessor. MP or MUP. Okay, now suppose this is the IC called as a microprocessor, and here I have connected a matrix keyboard or keyboard. So from keyboard I can send a data to this. So flow of data will be one directional. From processor, data will not be sent back to keyboard. But from keyboard, a data can be sent to the processor. So only one directional communication will be there. So let me show it by this arrow. Arrow indicates a way of communication or the way of traveling of data, keyboard to processor. Okay, here I have connected one monitor. For what? To display the content, result. Of course, the data will be result will flow from processor to output device. So data will flowing only in a one directional. Output device to processor. No, there will not be a flow of data. Let me show it by this way. Fine. And now with the memory. आता होता क्या बघा? These instructions are in a memory. Addition, subtraction, all the instructions are there. Those are there in a memory. So for execution, data will flow from memory to processor. Or timing, I feel that I don't want to display my result. My result must be saved in a memory. I don't want to display it. It should be saved in a memory. So in that case, data will flow back to memory. What I want to showcase? I want to showcase that this processor will not work alone. It has to work together with input devices, output devices, and memory. And then that will decide the definition. So we are going to end this lecture with the definition. And time is there. Wait. So I have explained this. Now what happens? This data and 10, 20, 30, 40, once I accept from the input device, before I go for processing, addition, subtraction, temporarily we must save that data in a processor. So in this processor, one segment must be there that is merely to store a data for temporary purpose. Before we are going for process, addition, subtraction, let me mark this. That section is called as register. In this processor, somewhere We have to go for actual addition, subtraction, multiplication, division, and or. So out of this entire IC, one section must be there where we are going to execute mathematical or logical operations. That portion, that section is called as arithmetic and logical unit, known as ALU. This is known to you. High section I. In this section only we perform addition subtraction. So I am saying at this point of time, the processor will not do anything else apart from addition, subtraction, multiplication, division, or and XOR. Logical operations and mathematical operations. Apart from this, it will do nothing. Right? But then some processes are very complicated. Some processes are very easy to handle. So for every unique process, every mathematical process, every logical process, every process of dealing with the input device, every process of dealing with the output device, every process of communicating with the memory, we require a typical time. Okay, let me give an example. If I'm communicating with the uh, guy who is residing in a Ratnagiri and I'm telling him about the area of Ratnagiri. So probably that boy is residing in Ratnagiri. He has information, good information about Ratnagiri area, and then I convey him the address. Yes, you have to go to that service stop, or otherwise this one. So that will be able to understand very easily because he is conversant with the area. So the way of communication with that boy is very less. With a small or lesser time, I can able to communicate the address to that boy. But if somebody resides in a Mumbai or in a Kolhapur, and I am discussing him about the area from Ratnagiri, probably he will not able to understand very easily. After a rigorous discussion, he may understand, yes, in Ratnagiri, this address, I will find the address here. Of course, that communication requires a larger time. Similarly, this processor communicates with input devices, requires a specific timing. This communicates with output devices, it requires specific timing. This will communicate with the memory for what? To accept the instructions or to save the result. It requires a specific time. So every operation requires a specific time. Who will specify it? That specific time for communication. Communication is give and take. For that communication, that time slot is given by one more block. The block is available in that IC or processor. This block is known as a control unit. It has to merely adjust a time required for communication, input device, time required for communication, output device, time for communication with the memory, time required for addition, time required for subtraction, time required for logical operations. Every process requires some time. That is known as CU, control unit. This is called as microprocessor. No, this is called as microprocessor system. Microprocessor alone will not work. Of course, it has to take some information from input device. It has to send the result from output device. It has to accept the program instructions from memory, and then only a system will work. So this system is called as a microprocessor system. Now, with this discussion, we are writing one definition and we will end our lecture. Of course, at the end, I'm going to tell you the reference books also. So, microprocessor is a device okay, which accepts the data from input. Please write down this microprocessor is a logical device which accepts, okay, accepts data from input accept instructions, addition, subtraction, multiplication, division from memory, accepts instructions from memory, data है 10, 20, instruction है addition, subtraction. It has to manipulate. Manipulate in an array. So input data is available, instructions are available. Now we have to go for computation. Manipulate within itself. Manipulate is not a proper word actually. Computation is proper word, but fine. It is manipulating data within itself. Now we got a result 10 plus 20, 30. So result can be saved in a memory or result can be sent to output device. Manipulates within itself and result can be stored in memory or sent to output device. This is known as microprocessor. Just wait, let me add some more words. Logical multipurpose. Device. Every word has a meaning. Logical. Why logical? It only knows the information like 1010. It doesn't know anything apart from 10. Everything input should be in a 1010 format. Instruction must be in a 1010 format. The output result will be obtained in a 1010 format. Every process happens inside the processor has to carry out in a 1010 format. It should be in a binary format. So the word is called as logical. Logic 1 or 0. It cuts. If I have to write my name, I will have to write S. S will be converted to 1010 format. That's called as ASCII code. U should be converted to 1010 format, ASCII code. So it only knows 1010 format. Okay, we'll see it afterwards. Multi-purpose. We can function mathematical logical operations. Accepts a data from input. Accepts the instruction from memory. Manipulates within itself and save the result either in a memory or we can display the result to output device. This is called as microprocessor, otherwise microprocessor based system. The next lecture we will convert this system to microcontroller and then we'll start our syllabus. But before I move to the last section of today's lecture, समझते what I'm teaching? Are you getting it? The way I'm moving ahead. See, let me ask you one more time. You can unmute yourself. You can unmute yourself. You can. No. Okay, they are saying yes.
Yes, sir.
Yes, sir.
Yes, yes. Thank you, thank you. Second thing is that I believe in a more interactive sessions. It should not be like a one-way communication. Always, you please ask me any sort of doubt. No problem. So please ask me. And then appeal to everyone. Please ask me the questions. Otherwise, the concept will not be get clear. Because this is a logical subject. It's not like, okay, of course, I like machines much, I mean, to teach. I like control systems to teach. But the way of teaching machine, the way of teaching control system, and the way of teaching BEE or the subject, high voltage engineering, HV, this is altogether different than the way of teaching to this controller. Because this is a controller based, I mean logical based subject. So I have to develop a logic in you. For that I require a frequent interaction. So please, I would like to suggest that please react on this one. try to give me some reactions, try to ask questions and get your doubts clear. Okay, before leaving, the book we refer for this. Ramesh Gaokar has written many books for microprocessor, and recently, as syllabus developed, he wrote the syllabus for book for our syllabus, PIC 18F 452 microcontroller. Ramesh Gaokar. This book is good as far as theory contents are concerned. Of course, 70% contents are theory contents in our examination, so you can go with this book. It's a very good book. Some more knowledge or information is required, or some C programming, which we see in the next half of this tenure. We'll go for deal with the C programming, and for C programming, we have to go for Majdi, embedded system design by Majdi. So, I mean, but this book is quite sufficient. If you want to go for more programming part, which is C programming, that time you have to go for Majdi. But right now we start with the now subject carries 150 marks, 20 marks I, 80 marks NSEM paper, 25 marks for term work, and 25 marks for oral examination. So total weightage, total this one is equal to 150. Okay. Wait a minute, let me collect the attendance and then I will allow you to leave the class. Wait.